Hello and welcome to this tutorial on how to write nested modules in Rust for libraries and binaries. Alright, so let's imagine a scenario where we have some sort of core functionality that is allowing us to connect to a database or connect to a queue, and then we have some domain logic that is describing some sort of database row and some sort of queue message, and this functionality needs to be shared across various scenarios, like for example an HTTP server or a command line utility, like for example this project, my mode main, with a main.rs file, or even some sort of lambda function that is scheduled in a cloud environment and wakes up every now and then to process data. So it makes sense to factor out all this code that is dealing with the database and the queue into a dedicated library, and in our case our project is called mymodelib, and you can see there's a lib.rs file and a dedicated cargo.toml file, and then share this library and import this library as a dependencies in all these other scenarios, like the HTTP server, the main file, some sort of command line utility, a lambda function, or whatever other scenario where we need this code that needs to be shared. Okay, so how do we import modules from other projects in Rust? And how do we traverse a hierarchy of directories to import other modules that are nested inside these modules? And how do we make this work together? Okay, so if you haven't seen a makefile before, no worries, it's not that difficult. A makefile is made of targets that, from our understanding, they're basically like functions, and they're just an easy way to wrap together multiple commands. So when we invoke the make command from the command line, if there's a makefile in the same directory, then we can say, for example, make run to invoke the command cargo run from the project called myModeMain, or we can do other things. So in our case, I just wanted to show you how we can wire up together multiple different things in order to be able to run them in an orchestrated way. So for example, here we have make tree, and we can see that we can print basically what's happening here in our tree explorer in our editor. And the reason why I wanted to show you this is because we can see how we created these projects in Rust. So our project myModeMain has been created with the command cargo new myModeMain / bin, which means we generate a main.rs file and the usual cargo.toml file for dependencies, and then cargo new mymodelib / lib to create this mymodelib project, which is of type library, and in fact we can see lib.rs and our cargo.toml file. Later we're gonna invoke make run to basically run this main.rs file. Okay, let's close this for now, and let's have a look at this main.rs file. Remember that our myModeMain project contains the main.rs file, and from here we need to point at code coming from this shared library called myModelib. So in order to do this, we need to do two different things: import myModelib as a dependency, and then use the use keyword to import functionality from this library. So the way we import mymodelib as a library, as a dependency, is via the cargo.toml file for this myModeMain project. And here you can see we specify mymodelib as a dependency with a path that is relative to myModeMain package. So here we go up one level in the hierarchy of directories, and then we go down one level in mymodelib to be able to import code from mymodelib. So here you can see the same. We are in myModeMain cargo.toml. We go up one level in our root project our root directory called modules example, and then we go down one level in mymodelib, where our lib.rs file lives and where there's a cargo.toml file. Okay, so we were able to point at this library, and now we use the use keyword to import functionality from this library. So how is this library structured? We pretend to have a database service to interact with the database. We pretend to have a queue service to interact with the queue. And then we have some domain functionality to describe this kind of interactions. So for example, in our model.rs file that is in our mymodelib library, we define a database row structure and a queue message structure. Okay, so let's have a look at this main function from the main.rs file in our project myModeMain. So we imported all this functionality from the library, and now we can use it. So for example, we can create a new database row. So this is a structure defined in our library here, and we can invoke functionality from this module. For example, print bar field, and we can invoke functionality from the database module here. For example, do call, which is returning a result as usual in Rust, and then basically we assert that this result is okay. And the same we're going to do with a queue. So we invoke this, we instantiate a new instance of this structure called queue message that is coming from our model.rs, this one. And then we are invoking functionality from the service called queue as we defined it here. And then we, as usual, our functionality in Rust is returning a result that could be either okay or error. So we make sure that the result is okay. All right, so let's talk a bit about how we expose functionality from a library in Rust. And the way we do this is via the pub keyword, which stands for public, which means we are not hiding this code from the outside. So we start from the lib.rs file, and you can see that we specify as public. So this is our myModelib project. We have the lib.rs file, and we specify as public our module called model and our module called service. So in model, we have a public structure. We have some traits with public functions that interact with this structure of type db row. And then we have a public structure called queueMessage. Our service module is actually a directory in our myModelib project. And in here, by convention, we have a mod.rs file, which is exposing as public two other modules, the db module and the Q module. And if we check what's inside this DB module and Q module, you see we are exposing functionality again with the pub keyword, like for example a function. And in Q is the same, we are exposing functionality with the pub keyword, and for example we're exposing a function. One thing, you can specify absolute path to import functionality from different files inside the same library. And here you can see how we use create to basically mean the fact that we are using an absolute path relative obviously to this library. So create means this source directory, and for example we are pointing at model, so create colon model means we are importing the functionality in model. And in fact here you can see that we are using model colon Q message to specify that the parameter that is used as an injection to this do call function is of that type. Okay, another thing worth noticing is that in our model.rs file, these structures have some fields that are not exposed as public, and in fact that they're automatically treated as private fields. So we cannot basically access this information from the outside. And an alternative way of accessing this information from the outside is via traits that we specify like this. So let me put all together here. So, well, okay, a bit better. So here you see we are specifying a structure. This field is not public, but because we have this function implemented in the trait, we are able to access this private field. And the way we use this is, for example, in our database.rs file, you see we are invoking this private functionality here. So we are printing this public field with the print line macro, but we are also accessing in the private fields with this function invoked on the instance of type dbrow. And the same we're doing even outside the mymodlib project. For example, in our mymod main project, in our main.rs file, here we are accessing this functionality with this syntax, which is equivalent to this syntax as you've seen here. And basically here we are able to interact with structures coming from the other library and invoke services and functions coming from these services from the other library. Okay, so let's go ahead and run this to see what is gonna print, and then we can check again where all these prints come from. So make run is going to invoke the command cargo.run from the project called mymodmain. And here you can see that we are printing something on the standard output. So where is this information coming from? Well, in our main.rs file, we are using some functionality from the library, and we are instantiating a new instance of this structure via the trait called new. And here, as you can see, we are implementing how this new function works. And so we are providing some defaults for the private field, and we are providing some injected parameter for the public field. And then we are invoking print.bar field, print bar field that comes from this trait. And this trait is able to access private fields like bar. Here you see there's no pub keyword in front of the bar field. And then we are invoking the service that we are importing like this. And this service is inside a service directory that holds a mod.rs file that is exposing this db module that is inside this file. And in here we are invoking again print bar field, but we are also printing our dbrow.full public field using the print line macro. Okay, so we've seen this stuff and we've seen these prints. The last thing we're gonna see is basically something very similar to the database scenario. So we are importing our queue functionality, and the reason why we are importing the queue functionality is because inside our mymodlib library we are exposing in the service directory in the mod.rs file our module called queue, which is this file queue.rs, as a public module. And because in our mymodlib project we have a lib.rs file where we are exposing the module service, the one defined here in mod.rs inside the service directory, as a public module, then we are able to traverse all the directories like mymodlib service queue. And in here in the queue.rs file you see the definition of this do call function, and as usual we're returning a result in like as you do in any kind of functionality in Rust, and we are accessing all the fields of this instance of type queueMessage. And this instance of type queueMessage is very simple, and basically it has two public fields, so there's no issue here like we've seen before with private fields. And we are able to basically invoke the print line macro and print in the standard output our queueMessage with all the fields and all the values for those fields. Just to recap one more time, the reason why from the main.rs file we're able to invoke functionality coming from our mymodlib library is because we have specified in our cargo.toml file for our mymod main project the other project as a dependency. So mymodlib is here with a path that we can access from this project, and so that means we are able to import all the code from this project into this project. Alright, so that's it for today. Happy Rust coding to everyone, and I will catch you on the next one.